Day 439 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3201. Find the maximum length of a valid subsequence 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums. A subsequence of nums with length x is called valid if it satisfies this condition right here. Sub of 0 plus sub of 1 mod 2 is equal to sub of 1 plus sub of 2 mod 2, and so on, all the way up to sub of x minus 2 plus sub of x minus 1 mod 2 is equal to those as well. Return the length of the longest valid subsequence of nums. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 2, 3, 4. Our output is 4. Explanation says the longest valid subsequence is 1, 2, 3, 4. So let's break down this example one step further so we can see exactly what it is that they're doing. So I'm going to copy and paste this over here so we can see what's going on. So first, sub of 0 plus sub of 1 mod 2 should be equal to sub of 1 plus sub of 2 mod 2. So what that means is we take 1 and 2, right? That's sub of 0 and sub of 1, index 0 and index 1. So we take 1 plus 2, we divide that by 2, or excuse me, we're going to mod 2, and that's going to give us a remainder of 1, right? So when we divide, so let's do it like this. 3 divided by 2 is going to equal, or it's going to give us, mod 2 is going to give us a remainder of 1, right? Because 2 goes into 3 one time, and there's going to be another remainder. It's going to be 1 left over for the remainder. So that has a remainder of 1. Boom. Then we do 2 and 3. So then we come down here and we do 2 plus 3. We mod that by 2. Boom. And that's going to give us a remainder as 1. So we can include this in our subsequence as well because they equal each other, right? So once again, that would be 5 mod 2. That's going to equal 1. Boom. And then finally, 3 plus 4. Boom. 3 plus 4. We mod 2. That's going to equal 1. Boom. So that'd be 7 mod 2 is going to equal 1 as well, right? So all of these equal 1, right? So that's why we can include this whole array as our valid subsequence, and the length of it is 4. So remember, we're not returning the subsequence itself, we're just returning the length of the subsequence. And in this case, the length is 4, so that's why output is 4, because when we do all of these and do the modular 2, it's going to give us a remainder. We're always going to get a remainder of 1, right? And so that's going to be important to understand when we're doing our code, because how we do our code, we're going to check to see if it's odd or even, right? If this adds up to be odd, and then this adds up to be odd, and then this adds up to be odd, then odd mod 2 is always going to be 1. So that's how we'll be able to keep track. And similarly, if they're all even, then the mod 2 will always be 0. So just so y'all can see, just to give y'all something else to help you better understand, an odd plus an odd is always going to be an even. Then an even plus an even is always going to be an even as well. Boom. And then an odd plus an even is always going to give us an odd. And so when we see this, an even mod 2 is always going to equal 0, and the odd mod 2 is always going to equal 1. So that's how we're going to be able to check if, or that's going to help us when we're writing our code to check to see if the two elements are going to equal each other, right? So because once we go through this array and we see, okay, that's an odd, 1 plus 2, that's an odd, boom. So we know that remainder is going to be a 1. Then we do 2 plus 3, that's an odd. So we know that remainder is going to be a 1. Then we do 3 plus 4, that's an odd. So we know that remainder is going to be a 1, right? 3 plus 4 is 7, 2 plus 3 is 5, 1 plus 2 is 3. They're all odds, so we all know that they're all going to have a remainder of 1, which is what we want, which is why our output is 4 and why we can include all of them. So I'm going to leave this up here while we go through this second example. So in example 2, we have our input nums equals an array of integers 1, 2, 1, 1, 2, 1, 2. This time the output is 6. Explanation says the longest valid subsequence is 1, 2, 1, 2, 1, 2. So in this case, it's a little tricky because as you can see, we have this extra 1. But it says a subsequence is an array of integers that can be derived from another by deleting some or no elements. So in this case, we're going to delete this 1, and then that will leave us with this, which will give us an output of 6, right? Because when we do this, boom, 1 plus 2, that's an odd. 1 plus 2 gives us 3, that's an odd. Boom, then we do this. 2 plus 1 equals 3, that's an odd. Then we get here, that's an even, but 1 plus 1 is 2, that's an even, but we're allowed to delete a 1. So then that's when we delete a 1 and we just come here. 1 plus 2, that's 3, that's an odd. Then 2 plus 1, that's 3, that's an odd. Then 1 plus 2 plus equals 3, that's an odd as well. And remember, an odd modular 2 is always going to equal 1. So that's how we got this subsequence right here, where it's always going to equal odd. When you add every two elements that are next to each other, it's always going to equal an odd, meaning when we the remainder will always be 1 when we divide that by 2. So that'd be 3 divide that by 2 is going to be a remainder of 1. That'd be 3 divide that by 2, it's a remainder of 1. That'd be 3 divide that by 2, remainder of 1, and so on and so on. So this is our full subsequence right here. Boom. And last but not least, let's take a look at example 3, where there's only 2 elements, but and the output is those 2 elements. So in example 3, we have our input nums equals an array of integers 1 and 3. Output is 2, says the longest valid subsequence is 1 and 3. So when we only have 2 elements, then we know that it's going to be 2 because there's nothing else for it to equal. So that's going to be even. But when we divide that by 2, it will be no remainder. Once again, even. Mod 2 is always going to equal 0. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult either. So let's get into it. Now, first thing we're going to do is we're going to create some counters for different types of subsequences. So first we're going to declare a variable called odd. We're going to set that to equal to 0, and that's going to be the length of the longest subsequences of only odd numbers. So we're just going to check for the odd numbers, right? So in this case it'd be 1 and 3 in this example. Then we're going to do the same thing, find the length of the longest subsequence of only even numbers. Or right now we're going to just declare a variable for it. So we're going to say var even, that equals 0. Then we need to do the length. So for that'd be just a 2 and a 4. Then we're going to do the length of the longest alternating subsequence starting with odd numbers. So once again, this is not a very long example, but once again, we're just going to do another one or this one's going to include even and odd, but it's going to start from the odd. So for that, we're going to say var odd even. So it's going to find the longest alternating subsequence starting with odd, then even. So For here, it start with the 1, then go 2, then 3, and so on. But then we're going to do the same thing where we start from even and get the length of the longest alternating subsequence, where we start from even, then go to odd. So for that, we declare a variable called even odd, and that will start right here, and then it go 2, 3, 4, so on. Boom. Oh, and set that equal to 0 as well. Now we're going to iterate through the nums array. So we're going to say for num and nums. We're going to open up the brackets, and we're going to say if num mod 2 equals 0, that means it's an even number. So we're going to that means the current number is even, so we can extend odd only subsequence. So we'll say odd plus equals 1, and then we'll say we can extend an even odd alternating subsequence as well. So we could say odd even equals even odd plus 1. Boom. Then else, if num mod 2 does not equal 0, we could say else, and we'll say that means the current number is odd, and we can extend even only subsequence by saying even plus equals 1. And then we can extend an odd even alternating subsequence by saying even odd equals odd even plus 1. Boom. Then all we have to do is return the maximum length from all 4 types. So for that, whichever one is longest, we're going to say return max, open up the parentheses, we're going to say odd, even, comma, even, odd. And it's going to return whichever one is longest, and that's going to get us the longest valid subsequence. So let's go ahead and give this a run. That's all the code, y'all. The code was that simple. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 3 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are some good numbers right there. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.